If we were to consider a few types of solutions as are really related to healthcare, let's look at isotonic, hypotonic, and hypertonic solutions. And this is really applicable to something like an IV. If we just need to give fluid to a patient, these three descriptions would describe the type of fluid that the patient is going to receive. And most often it's going to be an isotonic solution. The word iso, the prefix iso rather, means the same. So what we're giving to a patient is solution for which the salt concentration is the same as what's already in the body. And if that's the case, if we fill red blood cells, which have a certain salt concentration in them, fill them with isotonic solution in the surrounding, well, water is going to transport in and out. Remember, blood cells have semi-permeable membranes, so the water is allowed to transport in and out. But there's no osmotic pressure because the concentration of salt is the same on each side. And so there's no net water movement. The cells are going to stay the same size, and this can be used to hydrate a patient, right? The patient is getting dehydrated or they need to have plenty of fluid for some reason. You give them an isotonic solution. It's just like the water that's already there, and it's not going to cause any problems to the patient. Remember, this is not water. If we give water, that would cause big problems because water has a different salt concentration than what's already in the body. Isotonic solution is like saline, and that's what already exists in the body. 0.9% normal saline, 5% dextrose in water. The idea is that this is designed to match blood, and if this is to be given to a patient in an IV, I would say the majority of time something that's isotonic is what is desired. What about hypotonic solution? This is a dilute solution, meaning not enough, meaning less tonic, hypotonic, not as much salt as we would have otherwise. And if this is the case, well, this is a low osmotic pressure, meaning that inside of the cells is saltier than what we're putting in the outside. And remember that salt draws liquid in. So if the inside of the cell is saltier than the surroundings, water is going to be drawn into the cell, and that could cause cells to burst, right? Cells swell and they may burst because of the water that's going from the not salty enough solution into the cell, and that is just a reality of what would happen with hypotonic solution. There's some risks for this, right? We don't want to just give hypotonic solution, flippantly, right? It's important that this is only used to treat certain things because if there is not enough salt in the surrounding of the blood cells, osmosis will transport water into those blood cells and cells could burst. Some examples of hypotonic solutions: half normal saline, 33% NaCl, right? These are things that may be administered in the healthcare setting, and when they are done so, it is because this is what is needed in order to be best for the patient. If, again, we just have plain old red blood cells in a lab and we put hypotonic solution around it, then we would have the swelling and potentially the bursting. This is done to correct the fact that this is what's needed for the patient. A hypertonic solution, this is the opposite. This is too concentrated. Hyper means too much, and this causes a high osmotic pressure and water moving out of the cells, right? The outside is saltier, meaning that the water inside the cells want to go out to follow where the higher salt concentration is. This would pull water out of cells, could cause cellular dehydration, and again is not something that should be administered to rehydrate a patient. Here are some hypertonic solutions. So again, these are high concentration of salts, and we'll get into what these percentages mean very soon. A couple questions you might have are, when are hypotonic or hypertonic solutions even useful? And, I think that one of the biggest take-homes for this healthcare-focused nursing chemistry class is really just to recognize hypotonic, hypertonic, isotonic. They have labels, they have measurements, and then when it comes to solutions, this is really important to know about a solution as far as determining how it's going to interact with the body. Hypotonic solutions are useful when cells are dehydrated and need water. So the cells need to draw in some water. Providing a hypotonic solution would cause that to happen, right? It's saltier on the inside of the cell. On the outside, it's more watery, so the water will be transported inside. So this could be a use for a hypotonic solution. Hypertonic, right, pulls water out of cells. So the following conditions could cause for a want to pull water out of the cells. Cells are already swelling. We need to draw them down. A hypertonic solution could be good for that.